Welcome to Chem 1010. I'm excited to have you guys in class. We're going to begin by delving into the history of chemistry. Aristotle was a Greek philosopher, and he defined the four elements as fire, earth, air, and water. People accepted this because he was brilliant at the time, and this thought persisted for centuries. Then we have Antoine Lavoisier, centuries later, and he is known as the father of modern chemistry. He said that chemistry is the study of matter and its properties and is actually the central science in the way it connects to all the other sciences. Chemistry is integral to all the other sciences. In fact, whenever I took physics in college, I was shocked at how many of the formulas that I used in chemistry I actually applied in physics as well. Properties describe the characteristics and behavior of matter, and that includes the changes that matter undergoes. Matter is something that has mass and takes up space. So then what's mass? Mass is the amount of matter in an object or its measurement of an object's inertia. We can determine some of the properties of matter just simply by observing it. But to determine the properties, we need to actually experiment. We know that chemistry is integral into our daily life. We need vitamin C to survive. We love salt. We have salt in almost all of our foods because it gives the flavor that we need. Water, we need to drink water in order to survive. Our electronics often have lithium batteries, and our computers use semiconductors. All of these things would not be possible without chemistry. It took years to develop this technology that we have and rely on, and we don't always recognize the importance of chemistry in our lives. One thing that most people do but not realize is the scientific method. We make observations, we formulate hypotheses, and we design experiments. It might not be a formal experiment, but it is still a type of experiment that we're doing. We still test our theories, our hypotheses. For example, if you find a rubber ball that may have dried out some and it's hard, you could see if it still bounces. So you could think, well, I don't think it'll bounce. It's gotten pretty hard because it's pretty old. Let me test it out. So you made an observation, you have a hypothesis, and then you're going to experiment. You'll drop it to see if it bounces. If it does, you can still play with it. If it doesn't, it's not a bouncing ball anymore. There are two types of observations. You have a qualitative observation, and you have a quantitative observation. A qualitative observation doesn't depend on numbers. These are things like color, texture, smell, taste, state of matter. And then you have quantitative observations. Quantitative observations depend on numbers. So if you have difficulty delineating which is a qualitative and which is a quantitative observation, remember, quantitative has an N in it, just like numbers has an N in it. These observations have numbers in them. They're going to be your temperature, your volume, your length, your density, anything that has a temperature. Your hypothesis is just an explanation of the observations. You don't have any proof for it. You are just trying to make sense of what you've observed. Then you actually experiment. You take the systematic observations of measurements as you test for your hypothesis to see if you are correct. A law is a scientific description of a phenomena that allows for general predictions. So it's something that is always the case. Like, if this always happens, we know that it's a law. The law of definite proportions is one of those. And it states that chemical substances always contain the same proportions of elements by mass. For example, water is a chemical substance. No matter where we go in this world, in the universe, you will always find that water has 2 hydrogens for every 1 oxygen. A theory attempts to explain the observations, but it can change with more evidence. This has happened over time. We have the theory of relativity. We have the atomic theory. We have the theory of evolution. All of these attempt to explain what we've seen, but we don't have irrefutable proof that it happens in every single case. So it can change as we have increasing technology. The atomic theory is one of those. For example, we had Dalton, who listed his parts of the theory. And for what technology that we had at the time, it was awesome. But as we developed more technology, we were able to disprove things like an atom is indivisible, because we were able to actually split an atom, which is what we did in the atomic bomb, and what we do for nuclear fission, for nuclear power plants. So again, it's what you observe. The theory is based on your experiments, based on what you observe, but you know that it could still change based on new information. But with the information that you have right now, it works great. It's the best theory that we have. So as we look at this, we have an example of how we came to understand or create the theory of the asteroid hitting Earth to destroy the dinosaurs. They initially found iridium levels that were higher than normal in thin 66 million year old clay in Denmark and Italy. So then they started thinking about that, and they realized that asteroids are rich in iridium. So these high levels of iridium could be from an asteroid impact 66 million years ago, since that was the age of the clay. Then they experimented. They went through and took measurements at different sites around the world to test whether the high iridium in Denmark and Italy was only because in that area. What happened if there's 66 million year old clay in other parts of the world? Will it still have that iridium? Or will there even be 66 million year old clay in other areas? So they went all around the world and found that all the tested sites have higher than normal iridium levels in the 66 million year old clay. So they determined that there must be worldwide distribution of iridium, and that it might be due to the impact of a 10-kilometer diameter asteroid, because that would be the size that would be needed to create that impact, that widespread impact of iridium. So then they looked at asteroid impact shock fracture quartz and said, we'll need to analyze clay layer samples to find these quartz granules, shock quartz granules in this clay to see if it really is from the asteroid. They tested, they found that all the samples contained the shock quartz granules, but in the Western Hemisphere, there were significantly higher amounts of shock quartz granules. Using that information, they said, well, the impact site then is probably somewhere in the Western Hemisphere because most of the debris, of course, would be around where the asteroid hit. So then they started looking at the ages and sizes of known impact craters in North and South America. And they found the Manson crater in Iowa was the right age, but it was too small to have been produced by a 10-kilometer diameter asteroid that would be needed to make worldwide dust. And we know that 2/3 of Earth's surface is covered by water, so the impact site might be under the sea. So they start looking some more, and they find that there are ages and sizes of known impact craters and seabeds near North and South America whenever they start looking at imaging. Then they found this crater off the coast of Yucatan Peninsula in Mexico that was both the right age and the right size. So the theory is that a 10-kilometer diameter asteroid struck Earth 66 million years ago near what is now the coast of Mexico. And then dust from the impact blocked sunlight for months or even years, which resulted in the dinosaurs becoming extinct. This didn't happen overnight. The scientific method, whenever you're looking at an experiment at this scale, takes months or even years to implement. So remember, we're working at a snail's pace sometimes, and it feels like you're not making progress. But in reality, every little step you take is actually a good thing. It's actually coming closer to the answer. Here, I want you to pause and answer these practice questions on your own, and then come back and review the answers that we go over. So for this, we're going to ask ourselves, is this qualitative or quantitative observations? Remember, quantitative observations are the ones that have numbers. The first says the temperature is 74 degrees Fahrenheit. Is this qualitative or quantitative? This has a number, so it's quantitative. The quilt is soft. It's giving us a texture. There's no numbers, so this is qualitative. The lake is frozen. Again, no numbers. It's a state of matter. This is qualitative. And the baby weighed 6 pounds, 5 ounces at birth. That is quantitative. If you have questions about what's qualitative and quantitative, let me know so that I can help you. Here are some more practice questions. Again, stop, pause it, try it on your own, and then come back whenever you're ready to see if your answers were correct. For this, you're going to determine if the statement is a law, theory, an experiment, or hypothesis. Ice always floats on water. This is actually a law. It always happens. Birds evolved from dinosaurs. We don't know this is an absolute fact. This is a theory. It's our best guess based on the evidence that we have. It is not a law, so this would be a theory. Hot air is less dense than cold air, probably because the components of hot air are moving more rapidly. Probably because it's moving more rapidly. You're trying to explain something. So that would be a hypothesis that you would then test. When 10 grams of ice were added to 100 mils of water at 25 degrees Celsius, the temperature of the water decreased to 15.5 degrees Celsius after the ice melted. This is an experiment. It's telling you the steps, what happened during an experiment. The ingredients of ivory soap were analyzed to see whether it really is 99.44% pure as advertised. If it's being analyzed, it's being tested. If it's being tested, this is an experiment. One thing I want to bring up, a hypothesis, you only have observations. It's based only on observations. A theory is based on experimental evidence. Because I know some students get confused between a theory and a hypothesis. Hypothesis is at the beginning. You just say, I think this is what happened. A theory, this is based on experimental evidence you have collected. So you haven't just made observations, you've actually made observations, made a hypothesis, experimented, and then created a theory based on the evidence that you have. Let's take a break, and I will see you guys next time. Let me know if you have questions. Please feel free to reach out.